Good morning, good afternoon, or good evening, depending on where you're tuning in from today. I'd like to welcome you and thank you for joining this TechStrong learning experience with Harness. A couple of quick housekeeping notes. The session is going to be recorded. It will be available on demand afterwards. I will send you a link to the recording after we conclude. We do have some handouts in the resource section on the left side of your screen. Go ahead and make your way over there, click the resources, download the handouts, check those out anytime throughout the presentation. Make sure you've got them for after the webinar as well. Please, any questions that you have on the right side of your screen, answer or ask any questions in the question panel. We want to make sure that we have the questions to answer at the end of the program, and don't wait until the very end to ask your questions. Put them in at any point. And then we've also got the chat, which is just below the Q&A on the right side of your screen. Tell us where you're tuning in from, share your comments, share your understanding on the matter. We do want to engage with you, so make sure that you at least tell us where you're tuning in from, or tell us why you're here today. What do you want to get out of today's program? Let's go ahead and kick off today's topic. We've got Mastering Cloud Optimization, and we're joined with Karan Shetty, Senior Project Manager, where he's going to share some real-world strategies with you. Karan, thank you for joining us. I'm going to go ahead and turn it over to you.
Thanks, Jared. Welcome, everyone. So, as Jared mentioned, this webinar is mostly focused on how exactly Harness leverages all those features and how it can help you optimize your cloud costs and how to visualize the cloud cost. So I'll basically go and show slides related to what features or what techniques we use and how we manage our customers' cloud costs and how exactly we make sure we deliver those savings and what different methods or different features are available so that you can monitor your cloud costs and not only monitor and keep it optimized and having the savings rate and everything optimal. So the first feature which I want to talk about is cloud auto stopping. This is like a trademark feature available in Harness. Cloud auto stopping is nothing but you can basically shut down any of your idle cloud resources when they're inactive and bring them back when activity is detected. So what we have seen is this feature can deal up to 72% savings on your workloads or on your resources. And customers typically use it for workloads which don't need to run all the time, which can be your test workloads or your dev workloads, which usually have to be alive only when they're on demand, when your developers or when your resources want to use them. So keeping them alive 24/7 is just basically costing you a lot. So to solve these kind of issues, what we bought is called Cloud Auto Stopping feature. It can basically monitor any traffic across your resources, and as soon as the traffic is idle, then it can bring it down. And as soon as it detects the traffic back, it can restart it. So that way, you only switch on or keep your resources on when there is activity, and that saves a lot of costs. But as you know, cloud resources are expensive, especially if you run on demand or run resources which have like very high costs. So this will solve that and make sure your, especially your dev and test clusters or test resources are only switched alive when there is workload or when there's demand. So what exactly Cloud Auto Stopping supports is basically, as I said, it's an automatically stopping idle resources and restarting them on demand. It has support across the major multi-cloud providers, which is AWS, Azure, and GCP. It can work on various resources like EC2, VMs. If you have RDS, it can stop them too. Auto-scaling groups, instance groups, services in your ECS clusters, workloads and services in Kubernetes clusters too. So any of these workloads or services which you think in Kubernetes clusters might not be required all the time, it can detect them and make sure that they're switched on and switched off whenever required. That way, you're not running them all the time. What it does is it basically eliminates any manual intervention. You don't need to delete your pods or delete your services and make sure again run those templates, which basically have to be like a manual effort, which is eliminated by auto stopping. What it can do is basically just look at the traffic, or it can even do time-based schedule, which is like a simple schedule, which you can say what's the uptime, what's the downtime, and based on the uptime, it will make sure the resources are up, and based on downtime schedule, it will make sure the resources are down. So an example would be if you want your resources down on weekends, you can say, okay, on weekends I want it down, and on weekdays I want it up. So those kind of granularities can be added along with the traffic-based detection too. And also other levers, what auto stopping offers is it can optimize your spend by using spot instances. If you're not aware what spot instances are like instances or reserve capacity of cloud providers, wherein these instances have almost 60 to 70% lesser than the on-demand or the original instances. But the only caveat is this can be taken down anytime based on the demand, since these are reserve capacity. And the cloud providers provide you like a couple of minutes or less than that to terminate and handle all those events. So it can be tricky, but what we do is we make sure that when we are utilizing spot instances, if there are any termination, etc., we handle them and make sure we spin up more available spot instances. So all these things are handled by auto stopping. So you have resource level savings, and also you have traffic level or schedule level savings too. And also it offers hibernations and so on if you want to quickly restart or switch off your resource. Hibernate can help you with that. That way your in-memory resources are present, but only thing, it can easily or quickly switch off. So you can get those resources on demand faster. Additionally, what you can do is any resources which are under auto stopping shows you what level or what exact savings you're gaining by it. That way you can monitor and track and see what exactly you're saving using auto stopping. So it gives you a holistic view of basically managing your workloads, which don't need to be alive all the time, and can provide using spot instances, etc. It can save you additional 60 to 70% on the EC2 or on the VM resource itself. And additionally, as I said, like since you are not, since the resource is not alive all the time, you can gain more savings by that too. And everything is graphed, and you can see exactly how you're saving, what exactly you're saving, and so on. So cloud auto stopping is one of the feature. The next feature which I wanted to talk about is in auto stopping, we have something called as smart import for your Kubernetes, wherein what it does is when you use auto stopping in Kubernetes, all you need to do is install a controller which basically controls all the actions on the pods. If it has to kill the pods, if it has to switch on or restart or bring back the pods and so on, the controller does that. But it also installs an eBPF agent on each and every node. Through eBPF agent, what it does is it creates these smart maps or traffic maps with which you can easily import your resource. So since you have a lot of, especially in Kubernetes and so on, you might have a lot of complex ingress controllers, services, and workloads behind them. So when you create configurations, it's with such dependencies, it might be hard to basically create rules. So that alleviates all these problems. It creates a network map, and as soon as you click on those, it can basically not only import all the workloads, it can see what the dependencies are, since eBPF agent knows how the traffic is flowing and so on. So with one click, you can create all the roles. It will show you what savings you can gain and so on. So this makes the smart import makes it easier to consume and lesser effort to basically set it up. So this is specific for Kubernetes, and as I said, all the dependencies and everything, if you have complex setup, can easily be done by it. So this is how we can leverage auto stopping not only in your cloud environment, but also in Kubernetes environments, and make sure you run only when needed. The next feature which I want to mention is something called as commitment orchestrator. As you know, in cloud providers provide you commitments, which wherein you can make sure your compute needs are at a lesser cost, but all you need to do is basically sign in for a long-term based commitments, maybe 1 year or 3 years, and based on the term you sign, you'll get certain amount of savings. These savings are basically good, up to maybe from 20 to or 30 to almost 60%, depending on what term, what payment terms, etc., like for no upfront or full upfront. But the challenges with using commitments are your usage might be unpredictable. It can go up and down and so on. That makes it hard to leverage this automated without any automation, because you don't know how what would be your savings next month, whether or usage next month. What if your usage decreases? How exactly would you handle these RIs and savings plan? And also, since each cloud providers provide like various different commitment options, what would be the right fit for your workloads? And if you're using those long Excel sheets and other different tools, and if you there might be chances where you do those clerical errors, no, don't track properly or miss those. So you might miss savings, or you might get into commitments which you don't want to. And since these are long terms, this can have potentially bad effect on your cost wise. And as you know, any cost related impact can affect whole your organization. So so what we saw when we saw all these challenges, we thought, okay, we can help by leveraging AI. What commitment orchestrator does is it uses machine learning algorithms to basically predict the trend of your usage. That way, it knows how exactly your compute spend is trending, and based on that, it can predict and forecast what would be your usage in long term and over the months based on the data previously. And then it can handle and make sure that any stable usage are handled by reserved instances, which are more particular or for or more specific at instance type level, since these are consumed as instance type or specific to operating system and so on. You want these to be specific or reliable workloads. That way, we make sure that if there is a trend of instance types which have stable usage, we make sure reserved instances are applied to those, and to other types of instances which go up and down, which are like only basically alive for certain times. We try to use savings plan. So since savings plan can be consumed across your instance type, across your operating system, so it is more suitable to workloads which can go up and down. So we make sure those things are accounted for, and we automate all these purchases. So we basically manage your completely your commitment portfolio. All you need to do is connect your master account, and that way we know, okay, what your master, all your linked accounts, what's the usage, and based on that, our trend and forecast says what would be the exact plan suitable for your spends, what would be the exact RIs we can buy, exact savings plan. And if there's any drop in usage or if there's waste, we can easily convert them into whatever existing usage you have. So we have dashboards which show you how exactly you're saving by using commitments, what is your commitment portfolio, what's your coverage, and you can even specify how much of your compute spend you want to cover. By leveraging commitment orchestrator, basically you can make sure your commitments are have the maximum savings and minimal waste or underutilization. So this is one of the tools for your commitments, which the commitment orchestrator manages. So the next tool or the next lever which Harness offers is cluster orchestrator. So cluster orchestrator is nothing but node autoscaling for your EKS cluster. So the node autoscaler is based on Carpenter. So it's a Carpenter-based node autoscaler, and we add. So if you have an existing EKS or clusters which have Carpenter, we just use those packages and we add on or make it robust by adding few flavors of our own. Why is it better? Basically, what we do is we try to manage the Spot orchestration. As I said, Spot is a very good resource savings, but since it's unpredictable, we try to remove those unpredictability by making sure we can alternate if there's any interruption, or if your cloud provider takes those instances away. We can basically spin up a new Spot market in a different uh, or in a different market, which are more stable and so on. Since we know what the markets look like, we have those backend pricing and backend algorithms which keep on checking which markets are stable, which markets are good. So we can easily alternate and make sure that when the spot market is down, we can go to basically a more stable market. And if none of the spot markets are available, we can fall back to on demand. So that way we can guarantee that you always have your resources alive. Even though you are leveraging those spot instances, we make sure that you have an EC2 or VM always behind. So as I said, if spot markets are not available, we can fall back to on demand. And as soon as we fall back to on demand, we keep on checking if the spot markets are available, they're in good state, they're back up. And as soon as they're back up and in a good state, we can basically move those on demand back to spot. And that way, you can basically leverage spot instances back again. And we are not limited to just on demand. So it makes sure your savings are always available and make sure your availability is also in mind. So these alternation from spot to on demand and on demand to spot will help you leverage the savings and also make sure that availability is maintained. So that's what a cluster orchestrator offers. And additionally, it can also offer something called as workload distribution rule, wherein not only at node level, you can even specify at workload level what workloads or what namespace, or in a namespace, how many spot instance or how many on-demand instances I want to run. So that way you can split off your workloads at the workload level, and you can make sure your savings is guaranteed. But since few of your workloads are running in on-demand, they're always available. That way you can maintain your SLA and leverage spot instances and leverage those savings. So that's how a workload distribution rule can help. It can also, you can add like a base on demand capacity, or you can add different strategies. Making sure, like if you are running like dev test clusters, you can say, okay, I want spot markets which are more towards cost effective. Or if you're running like a production, you can make sure you use a strategy which is specific to availability. So these are all the strategies which cluster orchestrator offers, and make sure it optimizes your EKS or Kubernetes cluster to the extent which is maximum. As I said, the capabilities include Carpenter-based autoscaling, intelligent spot on demand autoscaling, and also if you are using our commitment orchestrator, you can even leverage that. And it will basically make sure that if there are any underutilized or unused RIs or savings plans, it can use them too. So that way you're using a full circle of spot on demand RIs and making sure your compute needs are always cost effective. Apart from that, it also provides granular visibility on your costs. So it provides you how much of your workloads are running, what's the cost associated with workloads, any idle storage costs, and so on. All these costs are visible. It provides a report on this. You can see which we call as perspective. So you can see a perspective of all these costs, all your node costs, all your costs associated with workloads, and see if there are teams who are basically using workloads which are at maybe higher levels based on resources and so on. You can easily detect with these reports. And apart from that, another important thing or capability which it offers is called as workload resizing. recommendations. So this is, as you know, in Kubernetes, resizing is or resource resizing is a big problem. A lot of them, a lot of resources or workloads which are pushed in Kubernetes are not exactly based on demand. So a lot of the CPU requests, memory requests, and memory limits are not exactly set based on what your usage is. So that could lead to CPU throttling, out of memory, and all those issues. So these resizing recommendations provide you recommendations on what exactly your workload resource limits or resource requests have to be set. And based on your strategies, like if you want it to be more cost effective or you want it to be more performance based, it will provide those recommendations, and you can go and set the recommendations, or you can even create, if there's an external team or anything, you can create Jira tickets and so on, and make sure those teams are aware of these recommendations and set those workloads based on that. So these are all the capabilities which are available with Cluster Orchestrator. Moving on, another tool which we offer is called as Asset Governance. This is nothing but governance as a code tool, which this is based on the open source Cloud Custodian, which has several codes which you can use for compliances related to cost, security, and so, or tag based. So if you want to make sure your resources have certain tags, if not, they have to be shut down or terminated, you can just add a code and say when to run, how to run. And asset governance will make sure any resources which don't match or which match those things will cleaned up. Below is an example. As you see, this is a resource, or this is a governance based on metric filter, which checks for the CPU utilization. And if the last 4 days CPU utilization is less than 30%, it can shut those instances down. So this provides you like a code-based approach wherein you can write code for several different resources. And since it's cloud custodian based, it has several different code layouts which you can use. And also we have AI which can help you write those codes based on whatever you want or whatever resources you need to shut down. So as I said, it works for any cloud, any resource, and any action. So using a simple code, you can basically manage those compliances, cost effectiveness, and leverage this lever to make sure your workloads are based on use those policies, are adhere to those policies, and they are optimized always. So just to a quick recap, in Kubernetes related optimization features which CCM offers is the cluster node autoscaling, which is the cluster orchestrator Carpenter based autoscaling, which not only autoscales your node but also handles spot lifecycle, which are nothing but during interruption, when the spot market is not available, so that it falls back to on demand. It also reverse those fallback back to spot instances. It provides workload sizing recommendations for your Kubernetes workloads. It can distribute your workloads based on spot and on-demand instances and even utilize RIs. It can bin pack additionally. So apart from Carpenter-based disruptions, you can also add harness-based bin packing, which adds an additional layer wherein you can make sure your bin packing is optimal and as per your needs. Apart from that, also, as the first slide said, our cloud auto stopping, wherein you can stop your idle resources or Kubernetes workloads, and that commitment orchestration, which basically makes sure your commitment portfolio is managed automatically and you don't have to do the heavy lifting. Everything is done by harness. And the last one is the cost governance, which is nothing but the code-based governance, which you can use for compliances. So these are all the CCM-based Kubernetes optimization features we offer. And to sum it up, including the automation, which are nothing but auto stopping, governance, commitment and cluster orchestrator. We also have visibility portfolios, which are nothing but perspective and dashboards, which shows you all the costs associated with the cloud providers across the services, across each and different line items. All these are fetched through Kerr. So all you need to do is connect your Kerr, and we will fetch and we will make sure we create those dashboards and reports for you. You can even categorize. If you have multiple cloud providers, you can make sure you can compare those reports, since your teams might work in different across different cloud providers. So you can basically add those buckets for each cloud provider as one, and you can compare in a single dashboard. You can compare multiple cloud provider costs too. So it helps different teams to visualize how exactly they're using, what exactly services they're using, and what exactly is the cost associated with it. Apart from that, we also have recommendations, which is nothing but it provides recommendations associated not only with your Kubernetes, it can also provide recommendations across EC2 or VM sizing based on your performance, CPU and memory performance. It can also provide your RDS and governance recommendations. And also additionally, you can add budgets to your workloads. You can say, okay, if it crosses certain budgets, please notify me. If there's any growth rate, etc., what would be my budget, what could be my forecasted budget, and so on can be also present. And the last thing is we also have anomalies, which uses machine learning algorithms and sees or highlights any anomalous spend or anomalous activities. That way, you're making sure it's covering your complete cloud provider and making sure anything which is not as per the current trend is highlighted, so that you guys can understand, okay, is this expected or not, and so on. And you can even give feedback to the anomalies which are highlighted. So in case it says, okay, this anomalous spend is basically due to on certain days, and you know that, okay, this is expected, then you can mark this as an expected anomaly, or you can say, okay, this is a false anomaly. So you can also add additional learning to machine learning algorithms, which takes that feedback and makes it better and better, and make sure based on your feedback, we provide those alerts which are very specific and which cater to your use case and to your whatever your cloud provider or cloud sees. So these are the few abilities across visibility and across automation which we provide. And I'll just give you a quick demo, a few of these resources, how exactly they look, what exactly they do, and so on. And then I'll just leave 10-15 minutes for Q&A. So let me quickly share my screen. Okay. So first I wanted to get into auto stopping. So as I said, auto stopping is nothing but idle-based resource stopping or idle-based management. It supports different cloud providers. So all you need to do is connect your specific cloud provider, and it has it basically, when you connect, is nothing but it creates a cross-account IAM role, which is very specific to your needs. What it does, it has granular IAM permissions. So in your connector, when you do, you can select what is your use case. Say you want to just stop EC2 instances, you can select, okay, I just want to stop EC2 instances, and the IAM role will have those specific policies. Or if you want to stop IDS, it will have policies specific to that. So that way you have more control in your IAM, and you don't need to keep it open for everything. So the setup is quite easy and more granular in that aspect. And all you need to do is basically select what resources you want. Make sure you want to shut down, you want to hibernate, add all those resources you want to shut down or hibernate, and then select whether you want them to be on spot, whether you want them to be on demand. And then you can add schedules if you want it to be schedule based, like have uptime and downtime schedules. Say if I want this EC2 instance to be up on say weekday, so I'll make sure like Monday to Friday they're always available at this time. Then I'll have like a downtime schedule on weekends. Saturday, Sunday, I want them to be switched off. So this is one of the scheduling lever which you can do. Then another layer is through traffic or the access layer, wherein if you have TCP or HTTPS traffic, you can make sure you either use load balancers or you can use auto stopping proxies, wherein it creates you can create an instance which basically routes all the traffic to the proxy instance which you create, and then based on that we will see okay if the instance has traffic or not, and we'll switch it off and switch it on. So you can specify all your ports, all your target ports, which we have to monitor for those traffics, select your application load balancers or create a proxies. And based on that, we will review and we'll make sure those auto stopping rules are created. And as soon as it's created, what we do is we provide you with savings, etc. If there are any savings based on stop, based on running state, if there are anything running, etc., we show that it's running. It has logs. It has any savings associated with those rules, and you can easily quickly stop, quickly connect to those instances too, and provides all those logs on when it will start, when it will stop, and so on. So this is a quick preview of auto stopping rule. I just wanted to show you, I have like a Kubernetes-based auto stopping rule already created. Right now, you can see that it is in stop state. The rule is in stop state. And if you see here, it is connected to a Kubernetes cluster here. And if I've said that if it's idle for 5 minutes, I basically want it to be switched off. So let me quickly go to the Kubernetes cluster. So this is the Kubernetes cluster. Right now, the pod, if I show the pods, you can see that it has a controller for Harness auto stopping. This is responsible for making sure what nodes, what's the traffic across your workloads, across your ingress, and so on. The setup for my pod is basically like it has an ingress controller, which is basically monitoring service and workloads, which is in basically namespace called as web demo. But as you can see right now, there's no resources in web demo because it's idle and shut down. So if I want to bring it up, I can just like go to the URL, which is basically I'm simulating a traffic there. So as soon as I click on the traffic, it first goes to our progress page, which is, okay, it's starting the cloud resources, which means quickly it should start those pods. As you can see, the pod has started. And as soon as it goes into running state, you will be able to see your resource. And if you see your auto stopping rule, in a couple of minutes, it shows up that it's warming up right now. And as soon as the pod goes into running state, it will go to start. So let's wait for a couple of minutes before it goes into running state. In the meantime, I just quickly wanted to show you a commitment portfolio, how exactly it is, what exactly you need to do. So in case of commitment portfolio, all you need to do is basically select what services you want to orchestrate, like ECS, RDS, and so on. For AWS, select connect a master account, which is nothing but your account which leverages or manages all your commitments. You just connect those, give the IAM permissions for that. Then after that, you can add any accounts or any instance types you want to exclude. This is in case if you have a certain cloud accounts which you think, okay, will be downsized or is going to be retired soon, or if you know that in certain instance types can be retired soon and you don't want to basically use them, you can exclude them too. And then you can say how much percentage of your compute spend you want to cover. Based on this compute spend, we will automatically use RI in savings plan and cover them. And you can also say how you want this commitment orchestration to be done. It can be done without approval, which is nothing but like an fully automated role, or it can provide recommendations based on wherein you can manually approve that too. And as soon as you click and set it up, you can see the details it provides. What is the savings breakdown? What is the spend breakdown across your commitment types? On demand, reserved, savings plan, spot instances. What's your coverage across these? And also what's your net amortized or unblended, if you have all those different views can be provided, and what is the utilization rates and so on. All these things will be provided. And you can even, if you have multiple master accounts, you can switch through it. If you have multiple regions, you can switch through it. And if you have multiple service like EC2, RDS, and so on, you can see all how your commitment portfolio exactly is going on. And to add to it, we also provide inventory. So whatever the inventory is there, you can easily and quickly see it. You don't need to go again to different tools, etc. Everything is available here. If there are any approvals or pending actions, it will come here. This is basically if you are in a manual mode, you'll get approvals which says, okay, these are the SPs or these are the RIs which is recommended and need to buy. And any actions which we perform, we can easily see what instances we bought, when did we buy, what we purchased, and so on. All these commitments and savings associated with the commitment are highlighted by the tool. So this is about the commitment orchestrator. Now let's quickly go and see, and we can see the web pod is running right now. So, and you can see that, okay, the service is back. And as soon as you clicked on the link, it's back. So this is very useful if you have workloads which don't need to be up. Based on those traffic or based on this, it can monitor the ingress traffic and make sure these pods are only alive when you need. So this is how auto-stopping works in Kubernetes. And similarly, it works the same for other different resources like EC2, RDS, and ECS, and so on. Monitors the traffic and switches up whenever you require it. Okay, so the next thing which I wanted to cover is something called as cluster orchestrator. So as you know, this cluster which I have demoed you on auto-stopping is behind an autoscaler, which is nothing but the cluster autoscaler. So the cluster autoscaler basically is the one which scaled up for the workload which you saw right now. And you can see that as soon as there was scale up, the pod was pending, it scaled up for an instance and spun up this on-demand instance or spot instance in this case, which was required. And so the orchestrator setup is simple. You just, if you have an existing EKS cluster or Carpenter, you just need to run a simple script which will install components such as cluster orchestrator, cluster orchestrator operator. This component is responsible for making sure the scaling actions, the scheduling actions, etc., are done by our cluster orchestrator. Then on each node, there's an interrupt listener which sits. If there are spot interruptions and so on, it can check on that and make sure the nodes are drained as quickly as possible, and then alternate to different spot markets and on demand and so on will be handled by that. And as soon as you install those scripts, it will install those components. All you need to do is basically then go and enable cluster preferences. If you want to add commitments, you can select which, if you have already set up the commitment orchestrator, select which master account you want RIs or SPs to be utilized in this cluster. A few Carpenter-based settings you can apply, TTL for Carpenter nodes. You can add the disruptions, which is offered by Carpenter. Say, okay, I want to delete the node after 2 minutes. Then also bin packing, additional bin packing, which is offered by Harness. You can say, okay, if my nodes have below 40% utilization, I want them to be basically bin packed more. And you can say if there are single replicas and so on, I'm fine with evicting it. So this is powered by Harness, and it offers like an additional layer along with Carpenter disruption to make sure your pods have been packed to the full and optimized to the full extent. Then the next would be spot preferences. You can say how much of your on-demand or how much of your spot instances you want. This is at node level. You can say what is your distribution strategy. You want it based on availability or cost. And you can also mention what would be the reverse fallback. That is nothing but when it goes to on-demand, what interval you want to basically, what intervals you want your system to try it out to move the on-demand instances back to spot. And also we have something called as replacement schedules, wherein you can have schedules for bin packing, the reverse fallback, and so on. Like have a custom schedule if you want like a particular type. Since these are disruptive events, you can control when these disruptions happen and make sure everything is smooth. Or you can set to always if it's like a dev or test cluster, or set to a custom time. If something in your production cluster, if there's like some event and you don't want any disruptions to happen, so you can make sure this bin packing doesn't happen during that time, or even those reverse fallback or other things don't happen. So there is a significant amount of control and significant amount of visibility on what exactly your Carpenter is auto-scaling, how exactly cluster autoscale is behaving. And I want to show quickly like how the workload distribution works in Cluster Orchestrator. So I have basically a distribution rule set up. Let's quickly show you the distribution rule. So I have a distribution rule called as distributed pods. As you can see, this distribution rule does nothing but it says any pods belong to the namespace test. I want 50% of it on demand and 50% on spot. Let's quickly go test this out and see if it can place these pods on spot and on demand. So let me quickly spin up a workload. So this is like a test workload, which is on the namespace test. And right now, if you see, there are no workloads on this namespace. Let me apply and see if there are these workloads. 4 of these replicas, 2 should be on spot and 2 should be on demand. And let's see if this happens. So we go and apply. So till the scale up happens, till the scale up and these pods get into run state, which will take a couple of minutes. Let's quickly go over the workloads and the node screen, and then we can come back to it and see how exactly the distribution is happening. So as I said, we provide you granularity at the workload level and node level. So if you click on view details, you can see your pod level or workload level granularity, see how your different departments are handling those costs, see how these web services, what's the idle cost, what's the storage cost, if there's any storage present, what's the memory cost, if there's any idleness associated with it, what's the CPU total cost, what's the CPU unallocated cost, and so on. All these things are easily visible. You can even set preferences if you want to show anomalies, you want to show any other different unallocated costs, and so on. So it provides you a report for your workload level. You can export it to CSV and so on and compare and do some math specific to it. And additionally, at node level, also you can see the same details. So at the node level, you can see what nodes are running in past 7 days, or change the filter to past month and so on, and see how many of them were on demand, what was spot, when they were created, what's their total cost, what's their total memory, and so on. And again, export them and basically see exactly how they're running, what are the costs associated with them, and so on. Now let's see. Okay, so as you can see, a lot of them are in container creation state. So there should be nodes which are spun up right now. You can see few of them spot and few of them on demand. So you can see like a spot and on demand node was created, and let's quickly do this. Let's see if 50% of the spots are placed in spot and 50 on demand. So you can see that 2 of these were placed in 200, 27,200, which is nothing but the on demand, and rest 2 were placed in 247,102, which are nothing but the spot. So this provides like a granular way, or like a way where you can make sure your workloads have specific SLAs, and make sure at workload level or namespace level you have those guarantees and you have those spot and on-demand distributions. This is what Cluster Orchestrator adds to a Carpenter-based node autoscale. And let's go quickly to the auto-stopping rule and see if it is in stop state. Okay, you can see now it's stopped state because it was idle, and you can see that it cooled it down, it triggered, and you can see everything in the logs that right now it's stop state. If I go and check the pod in the web demo namespace, you see the pod should be not running right now. So there are no resources, which shows that it checked the ingress controller, checked the services, and checked there's no traffic right now because no one's hitting that URL, and then put that pod into not running state. So these are the few optimization features. And additionally, one more thing is the recommendations, wherein your workloads, it provides those right-sizing recommendations, wherein you can see what is your cost optimized, performance optimized workloads, resource limits. You can tune it specifically to whatever you want. You can even create a Jira ticket if you want the teams to apply it or automatically apply it. So these are the optimization features. And additionally, you can also use the asset governance, which are, as I said, it is nothing but tool-based, wherein you can create a rule and apply those cloud custodian related policies. You can copy it from cloud custodian, or you can use an AI and say, okay, I want like AMI-based resource type, and it will provide you example of all those templates, and you can just copy it, paste it here, select the accounts you want running, select the region, and dry run it, and it will provide you all those outputs. And then you can, to make sure that as soon as you create those rules, you can create enforcements, which are nothing but you can say what rules you want to run, when do you want to run, what is the schedule for those things, and so on. So you want to run hourly, and an hourly rate, if you run, it shows you what are the evaluations. If I created like a unused AWS ESGs, it will show you if there were logs at that particular time. Did it identify any resources? And if there were any resources identified, you can see the JSON in table. Here is an example. It shows you all the S3 buckets which had this particular life cycle. Shows you what resources were identified, and if there were any actions performed, it will show you that too. So if you are basically eliminating any of these resources or eliminating this bucket, you'll see this. And additionally, it can even provide recommendations showing how much you are saving associated with these rules when these rules run, what's the success rate, what's the potential, and what are the additional recommendations associated with this rule. So these are the optimization levers or the features which Harness offers. And top of that, as I said before, it also has those reports which you can use across the cloud providers. You can basically see across, based on Kerr report, you can see what our product is, how much is using it across different services. You can see the different types of cost in AWS, in Azure, create cost category buckets across the different cloud providers, and then see reports based on that too. You can create custom dashboards. If you want to have like custom reports based on your configurations, you can do that too. And you can create budgets so that you get alerted based on your budget, what's the current spend, what's the forecasted spend. And if there are any anomalies associated with the spend, they'll be highlighted, and then you can go to that anomaly, say that it is resolved, or if it is something which is not accurate, you can even give the feedback to a machine learning algorithm. So I think we are at time. So I just provide you a lot of information. I hope few of it was useful and you could grasp it. But these are the capabilities which Harness offers associated with cloud cost optimization. And if you have any questions or anything, please let me know. I don't see any questions, but I see a few chats. Now's the time. If you have any questions, if you think anything else unclear, or if you need any documentation associated with these features, please let me know. I can send it out. And also, I see the question about recording. This will be definitely available after this webinar is done.
Yep. Yeah, Karan, I'm not seeing any questions either. So unless you have any final closing remarks, we can go ahead and close out.
Sure. So as Jayad mentioned, there are handouts which has our documentation. I just gave a documentation specific to auto-stopping, but you can see any feature which is there. Everything is, whatever was demoed will be available there. And also I provided a link to the presentation. You can reach out to me. My LinkedIn and everything is available. If you have any questions, you can always, and if you need any demo, please reach out to me. I hope this was helpful. And if there's any feedback or anything, please let me know. Thanks, everyone.
All right, Karan, I want to thank you for taking the time to join us. It has been a pleasure having you. And to our audience, just like Karan has said, and like I said at the beginning of the webinar, you do have these resources available to you. Go ahead and click in the resource section, download the handouts. I'll also make them available for the on-demand, so you can refer back to them if you need to. This program was recorded, so we will send you a link to the recording shortly after we conclude. And we do have a 1-minute survey in the resource section as well. If you can take that, it's 4 quick questions. It goes a long way. Your input is invaluable to us, so we would greatly appreciate that. Once again, thank you all for joining this TechStrong Learning Experience. It's been great having you, and we look forward to seeing you on the next one. Thank you, everyone.
Thanks, everyone. See you. Thanks for that.